Okay, so here's the last example for this section. Okay, we're going to start with, we've got 3 vertices, so these are just points. These are not vectors, okay, but we want to show that the triangle with those vertices is a right triangle, and then determine the area of the triangle. Show it's a right triangle. Again, this should lead to you thinking of 90 degrees, okay, when we're talking about vectors, dot product, okay, is equal to 0. Okay, if you like, you can do a little sketch of the triangle as well. B is at 0, 0. So I'm just going to roughly put C in here, 3, 2. That's C. Okay, and then A can be down here, and it's -2, 3. Okay, so something like that. So there's our triangle, and you can kind of start to see maybe there could be a right angle in there. Okay, so we can do that. If we do this with our vector work, what you would need to check for is we need to check to see how the vectors are related with one another. So we can do our vector BA, and we can find that vector by doing our subtraction from the origin, but since everything is 0 there, since we're going to the origin, BA then is just -2 and 3. Okay, and then we can do BC as well, which is equal to 3, 2. Okay, and we look for the dot product of the 2. So BA dotted with BC is equal to -2, 3 dotted with 3, 2, which then gives us a -6 plus a 6, which gives us 0. So now that we know that those vertices, if we did our vectors from there, they are perpendicular to one another. Therefore, right, we do have a 90-degree angle. Okay, because our dot product is 0. So that shows, therefore, triangle ABC is a right triangle. Okay. And we know that that's a right triangle because we just checked the dot product of the 2 vectors, and we saw the dot product was 0. What we had to do before when we were doing equations of lines, you'd have to check for the slopes, see if they're negative reciprocals of one another. Okay, find both equations of the lines. Okay, so now we can just do dot product and we're done. We can find a 90-degree angle there. Okay, so now if we wanted to find the area of the triangle, okay, to find the area of the triangle, ABC, we can use the legs that create the 90-degree angle. Okay, so I'm just going to draw it this way, just so we can see it, and I'll put the vertices where they are from before. B is here at the origin, A was up here. Okay, if we take it this way, this is your base all the time. So whenever you need to find the area of a right triangle, we can take the 2 legs, because that gives us the base and the height where they're 90 degrees, where they share the 90-degree angle. Okay, so we find the magnitude of each one. So the magnitude of BA is then equal to the square root, and then it's just our components. Again, this is just the Pythagorean theorem again. So for BA, it'll be -2 squared plus 3 squared, which then gives us the square root of 13. And we'll keep these as exact values until we get to the end. For BC, it's 3 squared plus 2 squared, which also gives us the square root of 13. Okay, And now we have our base. So square root of 13 here, square root of 13. We have the base and the height. Once we do that, we can find our area as 1/2 and BH 1/2 square root of 13 times square root of 13, which then is 1/2 of 13, which gives us 6.5 units squared. Okay, and that's our dot product 2.2, all the lessons. Okay, and then we'll start 2.3 tomorrow.